Hi there, my name's Chris Creed from the DMT lab at Birmingham City University in the UK, and thanks very much for your interest in our work around multimodal gaze interaction for creative design. So there's been a lot of work around eye gaze interaction over the past several decades, and in particular there's been lots of research around eye typing, selecting small targets, which is a known challenge in this field due to some of the limitations in accuracy of eye trackers, and also work around document navigation and other areas too. But one field where there's been a lack of work is around creative visual design work using gaze interaction, and this can actually result in some user groups being excluded. For example, people with physical impairments who might not have the option to use a mouse and keyboard for creative work. If they're reliant on gaze interaction as their primary input approach, and we don't have accessible interfaces to support them, they can essentially be excluded from this type of work. And also just incorporating gaze interaction into existing commercial design applications is unlikely to be an optimal approach. And just an example of that, I've got a screenshot here of Adobe XD, and we can see there are lots of small targets essentially within the interface. So for example, on the left, we've got all the icons for different tools, we've got the controls on the right. That's fine, they're straightforward to select using a traditional input device like a mouse, but if we try and use our eyes to select these tools, it becomes much more challenging. So we've been focusing very much on how can we make design tools more accessible for people who are using gaze interaction as their primary method of input. And to explore that, we've developed a new application called Sakura, which is a multimodal gaze design application. And by multimodal, I mean that there's a combination of using gaze for pointing at targets within the application, and then a mechanical switch is used for performing selections. And there's a screenshot of the interface here. So, and this was informed by the design of commercial applications. And we can see on the left, we've got a tools menu. In the center is the design canvas, and at the bottom, we've got the different controls for each tool. And just to run through the tools quickly from top to bottom. So at the top, number one, we have the object selection tool. Number two is the text creation and editing tool. The third one is for adding shapes and images to the canvas. The fourth is for document navigation. The fifth is for object alignment. And the sixth is the last one is for previewing your design. In terms of the controls at the bottom, I'll come on to those in a later video, just demonstrating how the application works. So one important point is just the interaction approach that we've taken within Sakura. So objects can only be manipulated via external controls, so the controls at the bottom of the application, as opposed to direct gaze fixations. And we took that decision, again, just due to some of the inherent limitations of eye tracking technology, and in terms of the accuracy of that, and pixel level precision and accuracy is very important, obviously, in creative tasks and design tasks. So we took the decision to make to ensure that objects can only be manipulated via external controls. So unfortunately, there isn't sufficient time to show all of the main features of Sakura, but there are three key features I'd like to focus on where there's been little work in the field to date around around a gaze interaction in more design-focused domains. So they are a new grid-based object selection approach that we've developed, how you can manipulate the size and location of objects, and also how you can align objects within Sakura. So initially then, in terms of our grid-based object selection approach, of course, object selection is a fundamental requirement for doing creative work, and that has to be an efficient process. But there are some unique challenges with this. So there could be distracting backgrounds, there might be overlapping objects. Of course, objects can be a variety of sizes and shapes, and that can make performing selections more challenging. And just to show you how the grid-based approach works, I've got a short video, and what the user is trying to do in this video is select the winter wilderness text just under the third image on the right. And to do that, they'll initially need to select the object selection tool in the top left. That will display the grid on top of the canvas. The user then needs to select the cell where their object is located. The first object in that cell will be highlighted, and then there'll be some left and right arrows or controls where the user can then navigate between the different objects within that cell. So I'll just play the video now so you can see that working. So the object selection tool has been selected, the grid is then displayed. So the user then navigates to the appropriate cell. The first object is highlighted with a red border around it, and then the controls are used. The right arrow is used to go onto the next object within that cell, and then that selects the appropriate object. So the key benefit of this approach is it reduces the impact of target size, in particular small targets, influencing selection accuracy. There's just a consistent approach for selecting targets of any size. So the second area I'd like to focus on is object manipulation and how you can manipulate the size and location of objects. And in traditional commercial applications, handles, for example, are commonly used, like the one circled here in Adobe XD. And these are efficient to use if you're able to use a mouse to manipulate those objects. But if you're using your eyes, then of course that's going to present challenges because it's a very small target. So in terms of demonstrating this, there's another short video here. And just to touch on the controls at the bottom, so we can see that the image on the right is currently highlighted, so it's got a red border around it. The controls at the bottom, the move tool, so the second from the left, is currently selected. The one next to that on the left of it is the resize tool. Next to those two tools, we have the directional arrows, which enable users to move objects in different directions or resize them in different directions. And we've also got an object transformation size feature, which is the button with 100 in it. And when the user selects that, it brings up another controls menu where users can select the size of transformations that they would like to perform on an object. So I'll just play the video now to demonstrate how this works. So you can see the right arrow is being used to move the object to the right, the left arrow up and down. The user then switches to the resize control. The object transformation size can be changed, so 10 has been selected here. And then by default it resizes objects bigger. But if you select the resize tool again, it goes red, and that means you can resize an object smaller, and then you can close the menu. So the benefit of this approach is that you have full control over an object's location and size without having to fixate directly on specific pixels within the canvas. That, of course, is always going to be a challenge because of the inherent limitations around the accuracy of eye tracking at the moment, whereas by using external controls, you have full control over the positioning and size of objects. So finally, object alignment. So alignment guides are very commonly used in design applications to help produce more professional outputs, and that can be through guides or grids. But as we can see in this screenshot of Photoshop, which has some vertical and horizontal guides, they're going to be challenging to select via eye gaze interaction because they're essentially very small targets. So just to demonstrate how this works within Sakura, so you can see the middle image here isn't snapped against a guide at the moment, a vertical guide. So what the user initially needs to do is select the alignment tool, which is the second from bottom. They then need to select the guide that they want to snap an object to. They then select the object that they want to snap to a guide, and then they use the snap control to actually perform that snapping action. So I'll just play the video for this to demonstrate how that works. So the alignment tool's been selected. So the user will then want the select a guide tool. So they're going to select a vertical guide, and they can toggle between the guides by using the controls there. So that guide's been selected. The user now needs to select the appropriate object they want to snap. So they've done that now, and then they use the snap control to actually then snap that object to the appropriate guide. So after developing Sakura, we wanted to evaluate whether it was an appropriate approach for doing design work. And we conducted a lab-based study to do that with 24 non-disabled participants. We used a Windows 10 PC with a 22-inch monitor, and of course Sakura was installed on the PC. We used the iTribe eye tracker, and we used a Jelly Bean switch to enable people to make selections. We developed this design using Sakura. And we essentially broke this in different ways and then asked participants to fix the issues. So for example, in one task we took out the text professional freelance photographer, and then they had to add that back in. And in another task we misaligned the images or some of the text and asked them to align it using the alignment guides. And there were 4 tasks in total that they were asked to complete. And then we administered an online survey where we asked about each of the key features developed. And in terms of the grid-based object selection approach, 22 participants provided positive comments, and there was a real emphasis on it being a fast and efficient approach. 7 participants did highlight that shifting their gaze between the canvas and the controls was potentially an issue. So if you're focusing on the controls at the bottom of the application, you can't necessarily see what's happening within the canvas. In terms of object manipulation, 20 participants provided positive comments around this approach. And again, there's an emphasis on the controls being simple, easy, and intuitive to use. For object alignment, similar theme, 19 participants provided positive feedback, and there was an emphasis on it being a fast, easy to use, and helpful tool. Although 3 participants did state that they found it a bit time consuming, and the fact they required numerous selections wasn't ideal for them. We also administered SAS and received a positive average score across all participants for that. So given the positive feedback we received, we wanted to do a follow-up study with some disabled participants. So we conducted a study with 6 participants with physical impairments. So 5 of those had motor neuron disease and 1 had multiple sclerosis. We conducted the study with 4 participants in their homes. 1 was at a social meetup for people with MND, and 1 was at our university lab. And the task we set people was to create this design from scratch, from a blank canvas. So we gave this design to them on paper, and then they had to start working towards that. But we encouraged them to deviate from this if they wanted to. Here's a photo just of one of the participants in their home. We used a laptop for this study. You can see the switch just in front of the laptop. So that's an example setup for this study. Sessions lasted between 90 to 120 minutes. All participants, we found, were able to utilize Sakura's features to create an initial design. Participant 5 and participant 6, their designs contained more canvas elements and more extensive use of alignment guides. And just an example of that is participant 6 design here. You can see there's a lot of use of guides, alignment guides, images, different text formatting, and obviously they had to move objects around to line this up appropriately. So this design took participant 6 50 minutes to complete. The other participants were able to utilize all of the tools and controls. Their designs typically just had fewer design elements in them. So after participants had completed the task, we did a semi-structured interview with each of them. We had positive feedback again. So participant 6, for example, said the system was intuitive, simple, and straightforward to use. But some of the participants did have some did have some issues. So in terms of the switch selection process, some of them found it challenging to perform a quick tap to actually accurately select a target within the application. This issue again came through about that disconnect between when you're looking at a control, you can't see what's happening on the canvas, and the starting position of new objects. That was something that was highlighted by 2 participants. So by default, new objects are placed towards the top left of the viewable canvas. Whereas actually 2 of the participants said it would be better to actually initially look approximately where you want the object to be placed, and then you can use the controls to nudge it into the correct final position. We again administered SAS at the end of the study, and again achieved a positive overall average score across all participants in terms of perceived levels of usability. So in terms of future work moving forward, there were some interesting points made by participants across both studies, and one of them was around multi-selection of objects and then performing transformations simultaneously, and that's an area where there's not been much work around gaze interaction for creative work. Also, using guides for as a means for determining the size of an object, so not just for snapping objects to a guide for layout purposes, but also using them to help support the size of objects. And also the creation of a pen tool so that users can create custom shapes via gaze input. And again, there's been a lack of work in the field around this particular area. Our future plans moving forward, we're currently doing more iterative work on Sakura, and our plans are in the near future to make this freely available online for others to use. So thank you very much for listening. If you have any questions about the paper and our work, then please do get in touch with me, and it would be great to hear from you. Thank you very much.